All right, we're going to do a reflection. We're going to use reflection to create two congruent triangles. Fold your patty paper at a diagonal, any place, but just make sure you save yourself more room. So don't make it too small. Don't make it too small like this, a little like this. So we're going to fold it. I'm going to fold it to right about here. And it doesn't have to be perfect. Increase it. When you open it back up, now you have your line of reflection. Okay, so let's go ahead and label that as our line of reflection. Okay, on your smaller side, you're going to draw yourself a triangle. Any old triangle will do. Okay, so you're going to close it back up. And you're going to flip it over so that this triangle that you just drew is on the bottom. Okay? So now if you look, your larger side is on the top and our smaller side is on the bottom. And you're going to trace it so that we can create a congruent triangle. Now this one is a little small. Maybe yours is a little bit bigger, I hope. Use your straight edge so that you can make sure that all the sides are congruent and nice and straight. Okay? Once you've created that, open it back up and you have your reflection. So you have two sides. If you want, you can darken it in. This was your original, this is your reflected side. So you might want to write that. This was the original, and this was the reflection. So if we label this to be triangle ABC, and we start here, triangle A, B, and C, and we want to make sure that we have triangle XYZ on this side, then we have to make sure that we label it appropriately. So this would have to be X, this would have to be Y, and this one would be Z. Remember, it's the reflection, so it's going to be kind of mirror each other. So Y and B are going to be right across from each other. A and X have to be across from each other, and C and Z have to be across from each other. Now, because we know that they are congruent, we can mark the angles and segments like we did previously. So I'm going to mark angle A, and then it matches angle X. Angle B is congruent to angle Y, and then angle C is congruent with angle Z. And then we do the same things with the segments. Segment AB is congruent to segment XY. Segment BC is congruent to segment YZ. And then segment AC is congruent to segment XZ. Okay, so now you have your triangles labeled, and you can write the statements there. One thing to note is that the distance between a point and the line of reflection is going to be equal to the distance between the reflected point and the line of reflection. That's going to be helpful when you're looking for problems that are asking you to find what the coordinate of a point would be once it was reflected around a line of symmetry. Okay, so we have our original and our reflection. We have our line of reflection. We can write our statements then. So we can say that triangle A, B, C is congruent to triangle X, Y, Z. And then we can write each of the statements that we just marked. So segment AB is congruent to segment XY. Segment BC is congruent to segment YZ. And segment CA is congruent to segment ZX. And then we can do the same things for the angles. Angle A is congruent to angle X. Oops. Angle B is congruent to angle Y, and angle C is congruent to angle Z. Now what you can also do is go ahead and you can dash this line in here just so you can see it a little bit better. And you can check the distance between A to your line of reflection and X to your line of reflection. It's probably very helpful for you to go ahead and check that measurement. You put your measurements in and they should match. Put your dashed line in here. And do the one between B and Y. And C and Z. And I'm just going to put points here so you can actually have your measurements here. And I'm going to call this M, this N, and this P. Okay? So your distance from A to M should be equal to the distance between X to M. These segments should be congruent. From B to N should be equal to Y to N. And C to P should be equal to Z to P. Your measures are going to be different than mine, but as long as you can remember that these distances are going to be the same, it'll make short work of those problems that are requiring you to try to find that other point if this was in a coordinate grid. Okay? So there you have it. Using reflection to create two congruent triangles, so we were able to identify the corresponding and congruent parts and of their segments and of their angles. And we also saw that the distance between a point and the line of reflection is going to be the same as the distance from the reflected point to the line of reflection. And that's it.